My name is Chris Bradford. We're talking about taking your database global with Kubernetes, which is a big statement. I want to toss a shout out here to Ty Morton from Google. He helped me with the initial version of this talk, co-presented it. So I want to make sure that we still have a nice reference to him here. There's a QR code on the screen right now that will take you to a slide share where so you can see all the slides. If it's easier to check out on your screen, feel free. But let's get started. So first of all, who am I? I'm Chris Bradford. I'm a product manager at DataStax, and I am the project lead for Cassandra, which is an open source project for running Apache Cassandra on Kubernetes. And let's get into what we're trying to do here, though. We're trying to run a globally distributed database. Some databases have the right primitives in place to do this kind of out of the box. But when you start talking about layering in technologies like Kubernetes, things can get a little bit tricky. That's why we're here in this room right now. But let's look at the shape of what we have right now. So we're running in a single region. We're going to use the GCP region names right now, but it really applies to any cloud provider. But we've got one region, 3 AZs, 6 Kubernetes workers that span all 3 of those AZs. Sometimes this is known as a regional cluster. And then 6 Cassandra pods, 1 per Kubernetes worker. We could have more. I guess you really can't have less, but that's the general shape of what we're looking at here. And this is kind of where we want to be. So here in this example, I'm talking about putting nodes on the East Coast, nodes on the West Coast. We're just doubling the size of our cluster. Why do we want to do this though? High availability, better performance, and geolocality. When I first saw Cassandra 6-7 years ago, I was like, man, if I can put my data closer to my users, I can run app servers on different sides of the country, even overseas in Europe or Asia. That would be fantastic. So I went to the Cassandra Summit, went home after that first day, just started tinkering with Cassandra, and it did not like anything that I was telling. I was like, you can't do this. Why? When you have a distributed database, specifically a vastly distributed database, i.e. sending queries across a WAN, that can be kind of an issue. But this isn't a talk about why Cassandra is awesome. We don't have enough time for that and all the Kubernetes stuff. So that's going to be the basis of how we're taking a database global. So I mentioned we just want to like scale this up, double it. Let's just copy and paste, right? We'll spin up another Kubernetes cluster managed, maybe one that we run ourselves, copy the YAMLs from one to the other, maybe change the name from US East to US West and call it done. It should just be simple, right? Just copy and paste. Yeah, sort of. In some cases, the answer is, yeah, maybe it might just work. It could work a little bit. It could work a lot of it. It could not work at all. I'm going to show you an environment here at the end that we have up and running that's working and talk about some of the specific issues that we hit trying to get that thing in a good spot. But like, congratulations if it just works. And for what it's worth, a number of the managed Kubernetes providers have done a lot of the plumbing for you to make this easier. Now, you might not know that it's been done, it just works, but some things might be configured in a way you're like, why is this not working? And you might just be like a firewall command away from happiness, right? But it's really that simple. And I think it's important that we understand kind of the building blocks here of what could be done for you, what you may have to do yourself. So when you start to approach something like this, you're asking the right questions and you're really laying down the right foundation and framework to succeed. So like some examples of things that you'd want to look at though, like your Kubernetes distribution, whether that be vanilla open source, maybe you're using something like K3s, managed Kubernetes like EKS, GKE, AKS. It all kind of mixes in there. And then you have, we'll talk about DNS for a little bit. I know many of us have probably had some experiences with DNS, positive and mostly negative. So we'll keep that in mind too. All of these kind of things can mix together into a hairball that we need to kind of detangle. So let's first start with networking though. And that's like the first hurdle that I really think that we're going to run into. If we look at our first cluster, we can see the layers of networking involved. So I'm going to talk about CIDR ranges. That's just a way to efficiently describe blocks of IP addresses. For what it's worth, I've been working with CIDR ranges for years now. I still hit the CIDR Wikipedia page at least once a week. Got a nice table there to help you cognitively understand where the heck these pieces go. So at the top level here, specifically at the VPC level or the region level, we have one address space. That's 10.100. From there, any virtual machine that's run inside of that VPC is given an address of that space. So you see the 3 Kubernetes workers here, each have like a 10.100.0.10.20. It's really whatever gets assigned to it inside of that VPC. Now, things get interesting then when we talk about Kubernetes. Kubernetes has its own networking layer that it encompasses, right? So I have a separate IP address space that's just used for items inside of that Kubernetes cluster. Now, it might be represented as a single sider like it's done here. In some cases, you'll see a couple different spaces for addresses, usually one for pods and one for services. Keep things simple, I'm just going to show you one, but it's not uncommon to see 2 or more. Now, from there, each Kubernetes worker, which is each node there, is given its own slice of that address range for pods that run on that worker. So here we can see all the pods here on the left column are 10.200.10.0/24. So it can have 200 plus addresses or pods running on that node. Usually it's scaled down a little, it's 100 and some change, but there's that much networking space available for that host. And then you see the actual pod that's running on that Kubernetes node worker is given an address from that space, and rinse and repeat for the other 2. So if we look back at our target cluster or clusters here, because these are separate Kubernetes clusters, what happens if I use the same address space, right? They're in separate VPCs, doesn't matter. Well, if I need to route across the clusters, maybe it does. Or what happens if they overlap? So when I first started thinking about this, I had a big nostalgia kick right here. I started thinking about these error messages that I'd encountered when I first started with networking, right? Hey, this IP address is already in use. So if I have a address space in cluster A that matches the address space in cluster B, and I send a packet out on cluster A, and I want to hit cluster B, it hits the routing table. And that Kubernetes cluster is like, oh, this is one of my addresses. Let me just ship it over to the right pod. And if that pod doesn't exist, which it doesn't because we're trying to talk to one in cluster B, that's not good. If a pod exists at that address and it's not running Cassandra, it's still not going to work the way we expect it to. There's no way for us to know, hey, this needs to leave this Kubernetes network, travel over the WAN, and get out to that remote VPC. Maybe it's the same network depending on your cloud provider, and then get into the network space of that other cluster. There are some projects that are working to tackle this in interesting ways. Submariner is a good example of that, where they use IPsec tunnels between your Kubernetes clusters. But it's if we are thinking about overlapping and conflicting cyberspaces, you're gonna have a bad time. And so this is one of the things that I really want to underscore. When you're going into a multi-cluster environment, pay very close attention to your address space. If you don't have that planned out and you say, oh, well, maybe we can just change it. In some cases, that involves tearing down your Kubernetes cluster and recreating it from scratch. So be careful there. Now, I've talked to some users, right? And they say, Chris, we don't have that many IP addresses. We can't just give every pod its own dedicated IP. It's like, oh, that's going to be difficult. So then we started talking about what services need dedicated non-overlapping IPs versus what services don't. And so a great example of this is when we think about a database, inherently it's stateful, right? It has data that you care about. If you think about your stateless services, they really don't need specific IP addresses that are individually routable. Maybe you can route to them over services or what have you, but we started to segment out, okay, what applications need this versus what applications don't. And for that particular user, they were able to say, okay, for our databases, we're going to make sure that they have dedicated IP space. There are some other solutions in the space we're going to talk about here in a second, though. So in that regard, we're talking about flattening out the network. And so here we can see we've assigned address spaces to each of the networks, to each of the nodes, and then the Kubernetes clusters are in different spaces. I think that says 250 over there, which is good. The first time I wrote this, I used IP addresses that were totally not valid. I was just in slide creation zone. It's like 10.300, 10.400. And then somebody was like, yeah, that stops at 255, bud. Yes, it does. Yes, it does. Thank you. So anyway, we've decided let's flatten out our network. Let's make sure we're not going to stomp all over each other's address spaces so we can effectively route packets between the clusters. So in some cases, this is just going to work out of the box, though. Like when it comes to how do we get to advertising this information. So if we go back to this slide here, how does the VPC level, so the 10.100 level, know how to route to the pod IP like 10.200.10.32, I think is, or .33 is the reference IP there. How does it know that that exists? And so if you're in a managed Kubernetes environment, what I've seen with a number of the cloud environments is that routing information is served up to the VPC routing table, which is awesome. That means like you could run a VM in the same VPC as your Kubernetes cluster and have it be able to route packets to the pods running inside of Kubernetes, which is a huge win. I did not want to have to do that, like update these routing tables, surface that information out there. That being said, there's some really cool solutions that have happened in this place. Back in 2016, Yahoo Japan put out a great article about running Kubernetes on OpenShift, OpenStack, on OpenStack, that's what it was. And they were using BGP reflectors. So the Kubernetes workers would then advertise out to their core networking layer, hey, these are the address spaces that I'm responsible for, update your routing, and ultimately send me packets. Now, I did mention there are other ways to do this. And so one option you might encounter is an overlay network. So what is an overlay network? It's a dedicated network space for your application. So I work at DataStax, and we actually put out an awesome blog post. My colleague, Ramon, put a blog post out, and it's linked in the reference section of these slides about how to set up an overlay network. And in that environment, there are networks that are specific to certain applications in the cluster. So they have, like I said, their own dedicated IP space that's independent of the pod IP space. And that gives you a little bit more flexibility because you aren't fighting with the IP addresses that are available for pods. You can kind of separate out your own space and determine who can connect to that specific network. That's using some really interesting, so I think in that particular blog post, we're talking about Envoy, but really any of these really fascinating network proxies that are sidecars on your pods can handle, okay, I've got a packet coming in from localhost. Where do I need to send this? Do I need to send this across the WAN to a gateway to a remote cluster and then it gets routed? So that's one approach, is to tackle with overlay networks. That's also a bit too much to go further into in this talk. So there's a link to that blog in the reference section. But what's next? We've got packets routing between our Kubernetes clusters. Big win. One of the interesting things about Kubernetes, though, is if a pod goes down, it can get restarted and it might get the same IP address. It might not. And when you think, I mentioned that state is kind of important and identity is important. So how do we have a consistently addressable identity to get to the pods that have the data that we're interested in? And in Cassandra, we've got multiple replicas. So like, I want to make sure that I can reach out and talk to the right pod that has the data, and it's there. So what we're really worried about here is dynamic IPs and how the heck we're going to resolve services across cluster boundaries. So in that overlay network thing I just mentioned, one of the cool things about that is we were able to give pods static IPs from that overlay network space. It wasn't the dynamically generated ones at the pod level. Super fascinating, big win in that column. But there's also DNS. And how can we, when we talk about DNS, like we have services inside of Kubernetes, you can also reference by the pod name and it'll give you the right IP and away you go. I've been burned by DNS before. I believe, was it 2 weeks ago, our friend Facebook got burned by DNS pretty severely. So like, do we really want to trust DNS, and how do we configure DNS to do what we want to do here? Kubernetes has a feature called DNS stubs. And if you look on the right side of the slide here, I have an example of what the stub looks like. And you can say, okay, for any DNS lookup that has this particular suffix, I want you to forward that query to this remote DNS server. And so what we've done here is we said, okay, if this suffix us-west4.cluster.local, if a query comes in for that, forward it to the DNS, the Kubernetes DNS service running in that remote cluster. And then on the other cluster, I have one that's pointed to US East in the realm of this example. So that's an option. And I've seen some people do this. If you look at, I've seen some docs for other distributed databases where they'll create a namespace inside of Kubernetes for US West 4 so they can set up the stubs and go that way. I'm not a big fan of this approach. I think it's fascinating, but I think there might be some better solutions here to kind of help us out. And again, you have to figure out, okay, this cluster is connected to these other clusters. I now have to have DNS stubs for all these. And one other gotcha is that .cluster.local there. In some Kubernetes environments, you can change that value. So I could maybe put my cluster identifier there at the end and not have to do this namespace switcheroo thing I'm not a big fan of. But more often than not, in our managed Kubernetes distros that are available, you can't change that. And that is not an option. So you have to do things like this namespace trick. There are distros that do allow you to do it. OpenShift is one of the ones that supports that out of the box, and I'm a big fan of. So there are some other solutions here. So you can either put together your own DNS solution. Good luck. You can use a managed DNS solution. So Google Cloud recently put out managed DNS, it's called Cloud DNS, not managed DNS. And this is pretty cool. They'll actually take the DNS entries for all of your Kubernetes clusters running inside of that VPC, replicate them up to the VPC level. So anything running in your VPC can resolve services and pods that exist in the Kubernetes clusters that exist within that VPC, which is pretty cool. Big fan. And I didn't have to write it, so double fan here. I would not be surprised if we saw this come out with some of the other vendors. And it's worth noting there are a bunch of DNS projects for Kubernetes. There's kubedns, there's core DNS. There's a number of options out there. And I think we're going to see a bit more growth in this space for service discovery across cluster boundaries. Now, KubeCon was literally last week. They talked about this a little bit with managed clusters from the multi-cluster SIG, where you can export specific services and then import them in other clusters, and it does the synchronization for you. I'm super excited about that because then you don't have to deal with any of this nonsense. But it's good to know that you have a number of options here. And ideally, you want to be able to do this resolution across cluster boundaries. There are some other workarounds. We're going to talk about that in the demo at the end, but let's keep on trucking. All right, so now what's another alternative here? So I was thinking about this networking space, this service discovery space. I said, well, let's talk about CNIs, the container networking interface. And I found that a number of CNI projects, providers, whatever you want to call them, support multi-cluster routing in an interesting way. Well, so Cilium is a great example where they'll run an entire mesh networking solution across all of your clusters. You can also get into a space with Istio here, where you again are using, this is sort of like that overlay model I mentioned previously, where you have these sidecars and these proxies that do the routing for you. You've got gateways to control ingress from other clusters and then routing. The interesting piece there is you have networking headers that are saying, where's this coming? Where's it going? Some gotchas there. If you're using your default MTU of 1500, you're going to see slower throughput because, well, you have extra routing information on each packet. But in most environments, you can get jumbo frames and be able to get up to 9,000. It's really not a problem. But it's worth being aware that some of these solutions exist. And with those solutions, you get some added benefits. So in the case of Cilium, they have a plugin for Cassandra where you can do, I want to say RBAC, but you can do access control at like the operation level at the network layer. So it can even say, hey, this particular application can do insert statements to this particular Cassandra table. This other one can only do selects and block it at that level. And I didn't have to set that up at the Cassandra level. That's enforced at the networking layer, which is really fascinating. We're going to see a lot more of this in the future. I know Istio has a number of plugins as well. They also bring in really fascinating pieces around observability. So you see here down at the bottom, that's showing how traffic is flowing through this system. I'm a big fan of the metrics that come out of the database because I'm a database nerd. But that being said, if I want to see the 30,000 foot view and see where that traffic is flowing, and specifically where it's not flowing well, that can help me in trying to diagnose, well, is it in my cluster? Is it in my crazy mesh network that I've set up? Is it, where's the disconnect happening? But let's talk about how we get from the slides that you've seen here to deployment. So I've got a couple of projects here. We have Helm, we have operator framework. If you're not in a single region or cluster, there's going to be a bit of juggling involved. And so the Kate Sander project that I work on, we started with Helm. And so when our users started to go multi-cluster, they'd have to do a Helm install or a Helm release per Kubernetes cluster that they're targeting. And they have to do some of the plumbing to say, okay, I'm talking to US West 4, I need to make sure I put in the connection information for US East and vice versa, right? And so it's not impossible. It's just a bunch of YAML files, right? If you're doing GitOps workflows, you check it in, you make sure everything looks good. But maybe there's a better way. And so we've seen this in some of the multi-cluster projects, especially around like service mesh, like Istio has like a multi-cluster control plane. And there's a couple of different ways you can do this, but I believe the operator space is getting a bit more robust around how we do multi-cluster operations. So specifically, you could have a control plane cluster where you say, hey, I want an installation that spans cluster boundaries, and it handles talking to the remote Kubernetes API servers and coordinates that for you. Maybe that control plane cluster is actually one of the clusters you're deploying into, which is the case of the demo here in a second. But also, like I mentioned with Istio and Linkerd, there are options to do where you have the brains or the operators running in each of these clusters, and they're communicating and coordinating tasks. And so some of these are a bit more advanced, like the Istio model. Some of them are up and coming. I think there's still a lot of innovation happening in this space, but it's something to keep an eye on. Now, what I'm saying is this is fine. Not everything is on fire, but I'll tell you what, if you just kind of, and I've done this, I've said, okay, I've got a Kubernetes cluster here, I've got a Kubernetes cluster here, let's go. And there was zero chance that it was ever going to work. I was going to have to spin down a cluster, reprovision it, tweak a couple settings. Oh, now I need to pair these two VPCs together. Like, if you do the planning up front, and I'm a big fan of having a notepad and start just writing down CIDRs and planning out where all this stuff is going to be, what am I going to do for DNS? It's going to pay off big, especially if you're working with NES, or if you are worried about like established clusters and that kind of thing. You don't want to have to redeploy and rebuild some environments from scratch because they won't play nice in this environment. So here are the references. It does nothing for y'all sitting here in the room or virtually. Check out the slides. I'll put a link to that back up before we wrap up here. But let's talk about what this looks like. I'm really keen to show you what the demo is shaped like. So let me switch a setting here so you can see my screen. Let's hope this works. Cool. We still good on Zoom back there? Sweet. Big shout out to the guy in the back that's helped me out here today. So here I've got two GKE clusters. You can see this one is on US East 4 and this one is in US Central 1. And I've got a Cassandra deployment spanning both these clusters. Is that big enough for everybody? I can make it a little bit bigger. Okay. So this is 2 3-node data centers, and I'm actually running the Cassandra operator here on US East 4, and it's named Cassandra 0. And so what I did is I installed the operator on this cluster, I installed the operator on my remote cluster, and here in Cassandra 0, I said, hey, I want to give you this Cassandra cluster object right here, and I'm going to describe the shape of it. There's a lot of metadata here, which we don't need, and a whole lot of status. I'm going to describe the shape of it. And so I was saying, hey, the cluster name is demo. Here's some configuration information. I'm going to name this first one DC1 and the second one down here is named DC2. Here's the basic information for the shape of my Cassandra nodes. And I submitted this to the cluster. Now, then it went out and said, okay, I've got a connection to my local control plane. That's easy. But I've also opened a connection to the remote control plane. And I'm now pushing these Cassandra data center resources. So here inside of this cluster, I have one named DC1, and then I have a second one here. So I was just sending some information to some of the engineers earlier named DC2. I'm going to push that out to those custom resources out. Then I have operators there that are going to pick up those custom resources and translate them into actual pods that are running. So we've got a stateful set here with 3 nodes inside of it. It handled stitching all the pieces together for me. I mentioned that sometimes this just works. In GKE, it's a single global network, so it worked pretty well. As far as the networking is concerned, I did have to add one firewall rule that said the worker IP address space for this region, plus the worker IP address space for this region, plus the Kubernetes address space for cluster A, and the Kubernetes cluster address space for cluster B. Those are all allowed to talk to each other. Please allow that communication. As soon as that firewall rule ran, it was able to connect to the control plane, it was able to deploy resources, and these nodes are able to see each other and work harmoniously. So in this type of deployment, I'd have app servers running in each of these regions, and they would talk to the local data center, so they have super fast access. We would stay available. We could lose a node, we could lose an AZ, we could lose an entire region. Our application would stay online and be available, which is the big win and the whole reason why this stuff exists. So that's the demo. Let's switch into questions. I'm going to bring the slide link back up just to be helpful. Anybody that wants to get I know it's here. There we go. So there's a QR code to slide share. If you're interested in the references, there's a whole stack of them there. Really interesting stuff. I do have a question on Zoom asking about, can I see previous sessions? I cannot answer that question because I don't know the answer to it, but I'm certain that the recordings will be available, if not soon, shortly after the conference. Any questions here in the room? No? Okay. Great. Well, I'm going to be here in this room for a little bit. There's a second session of this particular talk after lunch, but I think you got the high level details here. But if you think of something while you're going through lunch, please feel free to come back and ask it later. I also am joined by Kate Sander, team member over here, one of our engineering folks that's out of Raleigh. So if there are specific questions in the details, if I can't answer them, I'm going to tell you that he can. So awesome. Well, thank you so much.